Hello everyone. A very good morning to all of you. I'm Anand, welcoming you all on behalf of Solar Quarter and First View Group to our webinar on next generation solar inverter technology for rooftop solar, Jordan Edition. Thank you all the attendees for joining us today. I hope you had a great time networking with your peers in our exhibition tables. If you have not visited, no worries. The platform will be open till 1:30 p.m. after the session ends, so you can start networking. So before starting today's proceeding, I take this opportunity to thank and welcome our sponsor for this event, Huawei. So let me take you through the agenda for today. First, we'll have a presentation by our partners, Huawei, and then we'll move forward with our Power Pack panel discussion. Now, requesting my team to please play the sponsor video.
Is it that takes us further into the future? It exists in every visible detail, and somewhere in the unexplored possibilities. We imagine countless times that dry deserts become lush oases, and now it has become a reality. Sunlight spur a new ray of hope, make the earth green, and breathe new life everywhere. The size from rural to urban areas get simplified gradually, conserve the nature, and ensure seamless connectivity. Turning complexity into simplicity. Modular construction of data centers is designed for an intelligent digital world to unleash cloud computing potential and to accelerate the smart future. Speed up for future transport. For every pleasure travel, green power is used to achieve an excellent experience. Modular power can be highly integrated and applied everywhere. To light up the moments you are looking forward to. Bring unlimited possibilities and make life better and convenient. Huawei Digital Power. Preserve Earth with technologies. For zero carbon, smart society.
Thank you. So now, without any further ado, I would like to invite Mr. Omar Abu Nazem from Huawei Technologies to give his presentation. Come on the screen, sir.
Okay. First of all, thank you very much for this nice introduction. I will be going into my presentation, but before I would like to introduce myself. My name is Omar Najem. I'm responsible for the sales manager on Huawei Middle East based in Dubai and covering the whole area of Middle East. My presentation will be talking more about the new technologies and features about the rooftop solar inverters, which is we call it residential inverters. I will be as well covering some parts of the commercial, so we can give a full introduction about what the portfolio of Huawei has. I will be going into the presentation, but just one small question to the organizer. Can you see my screen right now, right?
Yes, sir. Yes, sir. It's visible.
Yeah, okay. I will be starting. First of all, I will be giving a company introduction about Huawei and solar department where it's located. Actually, in Huawei, as you all know, Huawei is a very big company. I will be giving an introduction and structure where the solar inverter are based. Fusion solar, the second topic will be about the fusion solar residential smart PV solutions, and a summary for overall the Huawei solutions that we can offer to the market. As I said, Huawei is a very big company that we are located in more than 170 countries and covering all regions. We're now almost around 194,000 employee, more than 96,000 of the employees working specially for the R&D center. We awarded as a number 14 in the research and institutes and centers. We're located in 14 areas, and number 5 in R&D and investment. For 2020, as we all know, that 2020 was very tough year for all of us, but we had increased in the sales revenue by around 65.7 billion US dollar, which is it was a year over year increase by 13.1% from 2019 up to 2020 first half of the year, H1 2021 2020. As I said, the power of Huawei is becoming from the R&D facilities that we're having, because most of the employees working on the R&D center that initiate and introducing a new technologies and solutions to the market. And this is one of the things that Huawei is different than any other supplier globally, okay, either for solar inverters or anything related to carrier business or enterprise business. The amount of R&D that we are spending, like for example, in between 2018 to 2019, we had invest more than 10% of our sales annually revenue. It's around $70 billion. Just Huawei's putting these numbers into R&D. That's why it gives us the number five ranked globally, okay, and AU especially. Regarding Huawei Solar, as I said, Huawei is located actually under something we called it digital power, and under this digital power, it's divided into five main sectors, let's say. Okay, the first one is the site power facilities that we are using into our other businesses, the DC facilities and data centers, and the smart PV, which is I'm talking about today, empower about the electric cars and electric vehicles as well, and modular power supply for charging and DC charging systems. We were leader into the market mainly the modular power supply, and because we are using these items into other businesses as well for DC facilities and data center, we were leading into the market of this power infrastructure, let's say it. Talking more about the inverter and inverter shipment, we have accumulative around 130 gigawatt global shipment by end of 2020. Okay, and we had a successful for the years starting from 2015 up to 2020. We were leading the brand as a number 1 inverter shipment globally. As we all know, Huawei is only focused on string inverter solutions, that it's replacing now the central or the, let's say, an old solutions, which is we put it as a central solutions. As we also between 2014 up to 2020, we saw the increase of using these technologies as Huawei implemented into the industrial. Between 2014 to 2020, we around jumped 60%. We replaced the central inverter by string solution, and as we can see it now, especially in the utility projects, that the developer and EPCs. They are going towards the string solutions in general. As in Huawei, as an inverter portfolio, we are covering a very wide range of applications, let's say. Okay, and it's divided into 3 main sections: residential, commercial, and industrial, and utility scale. Residential, we are covering both the single phase and 3-phase products. Single phase starting from 2 kilowatt up to 6 kilowatt as in single phase, and from 3 kilowatt up to 10 kilowatt, along with our optimizers and Lubna storage system, which is really popular in Europe mainly. For commercial and industrial, we put our portfolio starting from 12 up to 20 kilowatt, 30, 36, and 40 kilowatt, 50, 60 kilowatt, and 100 kilowatt. This is all for commercial, and we put it under commercial and industrial range. For utility, we are going higher with a higher output as an AC output, and these mainly products work for the utility. The product works for 800 volt AC as an output. It's mainly used for utility scale, and our main solution is 200 or 215. It depends on the application and the project. As I said, along with the inverters, we are supplying our STS station, transformer station, which is it comes like as a full turnkey solution from Huawei that include the solar inverters and transformer stations along with RMU, UPS, and switchgear. And we're having two types of this transformer station. The small one, which is STS 3000, 3 megawatt, and the other one is called STS 6 megawatt, 6000. Going into more detailed about what my topic is, I would be going into the residential and smart PV solution. As I said, our portfolio that can be divided into single or three-phase inverters along with our storage. As the audience now and the speakers will be talking about the fluctuation on the grid and how we can support the grid. For this is the ideas from Huawei. Sooner or later, the storage will be available into the market. The storage is a need for any distribution or utility companies. So that's why I think in the near future, Jordan is leading in this in technologies mainly, and I hope we can see it in the near future that there is some rules and regulations that we can apply it for storage, so we can support more the utility, we can support more the distribution company. This is a full background and simple single line diagram about our solution. We called it our inverter. It's not just an inverter that converts between DC and AC. We called it, it's a brain for the system. We called it in Huawei, it's a smart energy center, because it's not just, as I said, it's not just an DC AC unit. It's an intelligent and brain of the system that, as you can see here in the single line diagram, it consists of solar modules that we can connect our optimizers as an Huawei optimizers in these solutions and connected it to the inverter. And this benefit and gives as the inverter can see each panel by panel and monitoring each panel by panel. Now the optimizer is not just only because of there is a shade or what we can know before from the technology that it's just a bypass diode that gives us more yield or more energy if there is any shade, but also as in Huawei we add the features of monitoring each panel. If you are using an optimizers, it's a good idea to you can do O&M per each panel. And as I said, regarding the connection with our cloud, using either Wi-Fi system or Ethernet or 4G, as we're having as a smart logger or a Wi-Fi dongle or 4G dongle. So we're having all kinds of solutions that it can connect your inverter to the cloud or to the internet. So because basically the thing for Huawei is just not to commission your inverter using our platform, but doing all over the O&M monitoring purposes. If you want to control your inverter, you can control it through your mobile phone or your laptop. It depends which dongle or which monitoring platform you are using. And as well for the smart power sensor, which is as well provided from Huawei for some projects that needs a zero export, or you are doing a zero export or limitation in the exporting system. You have to use the smart power sensor, which is this power sensor mainly gives command back and forth between the inverter and smart power sensor and between the grid and the inverter. So it gives you the needed energy that it requested, as long as the solution which is we are providing and now is really popular mainly in Europe, the smart string ESS. This is a storage system from Huawei that connects to the inverter along with a backup box for some emergency load and emergency cut when the grid is cut off. This is mainly for emergency. I will be jumping into more information about the optimizers and how Huawei is developing optimizer. As I said, it's not only just because of there is some shades on some modules. It's one of the benefits of using optimizer, but it's not just because of this. We are using optimizer as well to increase the awareness of any end user about the system that he's having. If there is any failure, micro crack, anything regarding the module, especially module by module, we are introducing the idea of using optimizers. And along with this, our inverter can be working partial optimizer for partial project optimizer or a full optimizer project. For some old, let's say, technologies of optimizers, if you are going towards using optimizers in your project, you have to install optimizer on all panels. But for Huawei is different because we can use partial or full optimizer solution, and both of them they will be in directly giving command to the inverter as well. Giving more detailed about the battery and ESS, as I said, this is really popular now in Europe due to the idea of the battery is not just because of the inverter will be working as an on-grid or on off-grid, but mainly when we're having the tariff that it's mainly popular in Europe, the tariff which is day-night tariff, and you're having the peak hours. The people in Europe mainly going towards the storage, especially in Germany, just to save more on their bills when they are going into the high tariff. For the battery will be giving the energy directly from the battery instead of having it from the grid. And this is a simple chart of what we can provide into the market. Going into the technologies about Huawei's inverter, one of the main technologies is the active safety. Active safety means that we're having the latest AFCI function, and this AFCI function, it's really important as well, not only for the safety for O&M. When you're doing O&M, you know, some of the workers or the people on sites, when they are doing the cabling, trenching, all of these, sometimes the cable got damaged, and this damage we can't see it by just our natural eyes. If this damage increased later on and starting to give an arc or happening an arc, the system, it caused may a fire. So that's why we had this function that the inverter will be turning off within zero 0.5 second as the inverter detect any arc in any string that is coming into the inverter. So the inverter will be switching off. This is something related to the safety of the inverter and safety for the grid as well. And we hope that we can see these safety requirements from the regulatory or the distribution companies as well later on, because it's good for the end user, it's good for the utility or for the distribution company to have these functions available and on their solar projects. Of course, about AI and artificial intelligence systems, active arcing protection gives very big advantage for Huawei, mainly for the countries that you should be having, and you must have these features built in within any inverters. Like if we're talking mainly about Europe, and we know that Jordan is developing the systems, and the regulatory from Jordan, they are developing the system towards Europe standards, and we are using these Europe standards as well in Jordan. So it's good as well for Jordan projects and Jordan rooftop projects to be having these kinds of solutions. As I said, this arc fault, or what we called it AFCI, it's available in our products either from single phase or from 3-phase up to 10 kilowatt, or we called it single phase L1 system or M1 system. And I said as I said before, the shutdown time will be less than 0.5 second, which is it's different than the old an IEC standards, which is the shutdown time should be less than 2.5 second. But Huawei go along with this to make it 0.5 second. So this is 100% ARC support and ARC safety for the projects.
Mr. Omar,
Yes.
we already spent 16 minutes. I will give you another 2 minutes maximum.
Okay. Okay.
And
I'm almost finished. I'm
yeah,
almost finished.
excellent. And if you want, we can send the presentation with your email to the attendees later on, so they can ask you more detailed questions.
Yes, Anna, I'm almost finished. I
Perfect.
would be just the small part about the storage, and as I said about no worry about power outage, but just not only the battery, just because of the power outage, but we are using it for different solutions when the tariff is different. This is the auto detection system that Huawei's platform, or Huawei, what we call the Fusion Solar application, that you can connect all of your projects through your mobile phone. For the end user or developer, he can see exactly what the system is producing and what failure that happens into the system, especially and spontaneously on your mobile phone. This is depends on the application about using Wi-Fi dongle or 4G dongle. It's gives a wider as well option for any end user if you don't want to them to connect to your local Wi-Fi network. We can use instead of local Wi-Fi dongle is a 4G solutions, and especially for rare areas and the areas that it doesn't support the Wi-Fi. We can use our 4G dongles in this. And this is my end of presentation. Thank you all. I'm really sorry if I took long. And as Mr. Samer said, I will be sending this presentation to all of audience if they're having any questions. Thank you very much again.
Thank you very much, Omar. Fantastic presentation. I'm sure we will have questions at the end of the QA
Yes,
session
yes, sir.
after our distinguished speakers. Yes, Anand?
Yes, sir. So, thank you, Omar sir, for this insightful presentation and for setting the tone for today's event. So, now moving ahead with our much awaited panel discussion, which is on next generation solar inverter technology for rooftop solar projects. This discussion will be led by Mr. Samir Zawad sir. Who's an independent engineer having a 30-year experience and an experience of 20 years in energy market of Jordan. So over to you, sir. Please take this discussion ahead.
Thank you very much, Anand. It's a pleasure to moderate this session. We have five speakers. Our first speaker is Mr. Farah Qaqish. Farah is a mechanical engineer. He is the Deputy General Manager for the Energy Efficiency and Renewable Energy Department at Izzat Marji Group, and he is a dear friend. He's been leading this effort for the past 12 years. Um, Farah, we are talking about
Yes.
inverters today, and can you shed some light about how inverters help in the levelized cost of energy management?
Yes. I would like
Thank you.
to firstly thank First View Group and thank you, Mr. Samer Zawaide, for this great introduction and inviting me for this panel discussion. I'm sure it will be of a great benefit to all attendees. As we all know, Jordan was one of the leading countries in the MENA region to adapt the global trend into turning into going green, whether in the production of electricity and in the green economy as well. Now, since day one, most of the manufacturers were obliged to, or the EPCs in Jordan were obliged to install only good brands and good quality of PV inverters. The main reason behind that was the current regulations, which require having specific brands and specifications for the used inverter. Mainly, the used inverters in the local market have an acceptable range of efficiencies. The efficiency is the main factor in the calculations of the exported energy and the produced energy by the solar PV system. Now, this will have great impact on the annual generations as well, and this is what matters in the calculations for the project owners. Going very simple in the calculations, for a 1 megawatt project, for example, each 1% of the efficiency of the inverter itself will have an effect of 4,000 US dollars per year. Of course, based on the commercial tariff of the Jordanian tariffs. This means 100,000 US dollars per the project lifetime of 25 years. Now, if we take a deeper look at the equation, or the simple equation for calculating the levelized cost of energy, now this parameter can be calculated by dividing the present value of total costs for the project over the lifetime of it by the present value of all electricity generated over the lifetime. As the equation also includes the costs of operation and maintenance of the system, this also means that the inverter quality must be very good, so we reduce the costs of the required operation and maintenance and the expenses associated with it, and therefore we reduce the levelized cost of energy. One last thing, the avoided carbon emissions, the CO2 avoided emissions, have not only a great impact on the environment, but also the project owner will have the right to sell their avoided emissions and to reduce the levelized cost of energy further. This was my personal, very simple interference to this subject, and I thank you again for this nice opportunity, and I'll be more than ready to answer any related questions regarding the levelized cost of energy later on at the QA sessions.
Thank you very much, Farah, but I want you to repeat again the 1% the efficiency and the 4,000, because I didn't really understand how you what size PV plant you're talking about.
Of course. Making a very simple calculations, if we consider a project capacity of 1 megawatt peak, and I assume that the tariff, the electricity tariff, is the commercial tariff in Jordan. If we calculate the efficiency, let's say from 99% to 98%, that's 1% deviation. This 1% will have an impact of 4,000 US dollar per year. If we calculate, for example, the specific yield to be 1,600 kilowatt hour per kilowatt peak per year. So this is the very simple calculations, but it leads to a lots of energy that might be wasted if we go with a low efficiency inverter, or gained if we select one of the good inverters in the market. So how about going from 99% efficiency inverter to, for example, 90%? That's 9%. This will lead to more than 30,000 US dollars of savings per year.
Yeah, I got you. Thank you very much, Farah.
Yeah, no problem.
Well said, well said. Our next speaker is Marissa. Marissa, are you with us? Anand, is Marissa with us?
No, sir. She was not able to join us today.
Okay, then we will go to our third speaker, Miss Lubna. Miss Lubna, are you with us?
Yes, yes. Yeah.
Excellent. Miss Lubna is working as project manager for Qawar Energy. Qawar Energy is one of the leading companies in the solar PV utility scale and market, and the rooftop market as well. She has a master's degree in renewable energy from Mu'ta University, and she has 3 years experience with 15 megawatt of installed capacity under her belt. Lubna we would like you to tell us a little bit more about how power quality is impacted by smart inverters.
Yeah, okay. Hello, Engineer Samer, how are you? And hi for all of the attendees here. I want to talk about the power equality. The power equality is the main issue have become increasingly important in the distribution grid with the widespread use of non-linear electronic equipment. When we talk about non-linear electronic equipment, we hello?
Yes, go ahead. We hear you.
Yes, I think I have a problem with the mic. I don't know why. Okay. When we talk about the power equality, we mean here inverter. The inverter consists of non-linear electronic equipment. This non-linear equipment sorry, the inverter cause a problem that affect the stability of the power system because it is a switching device, okay, served to adjust frequency for the AC power as needed. At the same time, it can cause the harmonic. The harmonic is the main problem that affects the power stability in the grid. It make a waveform distortion and affect electronic devices that receive the power. Then it could make electric device malfunctions. Also, I can talk about what is the main problems that faced the power equality is appear as a voltage dip, fluctuations, transient phenomena, and reverse power flow. Also, we can talk about sags and transit. All of these problems affect the power equality and the on the grid. Also, the power equality is the general term given to represent an AC power system freedom from harmonic content. And the power equality meter is one that gives some form of harmonic content indication. Okay. Also, we have indicator that give us the how the inverter make a problem in the power plant by a concept is a total harmonic distortions. We have a percent if the current, if the total harmonic distortion in the current or the voltage exceed this rate, it make a big problem, and we cannot connect the power plant to the grid. Voltage equality impact all equipment specifications will be subject to relevant grid codes and intermittent power supply codes. Also, okay, there is a lot of topics about power equality, but the main subject, as I mentioned, is the harmonic. And what is the harmonic? The harmonic is a distortion happened in the sinusoidal waveform. It make problems to the electrical waveform, so we cannot connect it to the grid. Nowadays, the inverters consist of filter that make the waveform as a size as a sine wave, so we can connect it to the grid. I think this is the main topic. It's a small topic, I think, but it's very important to find the rates of the total harmonic distortions that reduce by inverter, and that's it.
Thank you very much, Lubna. It's not a question, but I want you to focus on if you can tell us from your experience what you saw in the Jordanian market from fluctuation, from the what kind of impact, let's say, the grid, the distribution grid has on the the inverters in your 15 megawatt of rooftops?
Yeah, yeah, okay. We using power quality analyzer to find the total harmonic distortions for the waveform that comes from the power plant. If we have the rate is less than the range, we can connect the power plant to the grid without any problems. The electrical companies in Jordan always track this rate of total harmonic distortions, and it comes from inverters. Why inverter? Because the inverters consist non-linear devices. Those non-linear devices make us switches to convert the signal from DC form to the AC form. I think this problem not common find in a small project like less than 1 mega project, but maybe we can find it large in larger projects above 5 mega or 20 mega. Because we have in the large scale projects a big number of inverters, so we focused on find the harmonic rates in this project more than the smaller projects. Mhm.
Yeah, okay, but as far as power quality, what you're seeing in the market, you don't see any problems with the small scale, but on the large scale, maybe.
Yes.
Okay, I'm sure that our attendees will have questions for you, and this is a call out for the attendees. If you have any questions, please write them in the chat, and we will read them and direct them to the specific speaker at the end of the session.
Sure.
Thank you very much, Lubna, for this nice discussion. And our fourth speaker is Mr. Laith. Laith, are you with us?
Yes,
Excellent. Mr. Laith is a dear friend. He's an electrical engineer, of course. He has a master's degree in renewable energy from Germany. He has 13 years in the solar PV sector, and he's working as a consultant, and he has his own company providing testing commissioning for rooftop and utility scale projects. So we are very happy that Laith is with us today. Laith, can you give us a little bit of an idea about the smart monitoring of smart inverters right now? What is available in the market, and what do you recommend for the consultants, such like yourself, to include in the tenders, and what to expect in 2022? Thank you.
Okay, thank you, Samer, and thank you guys for this session. Actually, I want to talk about the monitoring in general and how it's becoming smart and smart day by day. I like, by the way, the presentation done by Engineer Omar. The issue here that I want to focus on, that what can smart monitoring do in maintenance, and how it can provide less OPEX comparing to general monitoring, what I can call is the traditional monitoring. So from my opinion, and as we see day by day, like Huawei, like many suppliers, even there are now specialized companies in providing smart monitoring for PV systems. So the issue here that you can have many advantages compared to the traditional monitoring. You can collect the data. You can also connect with the meteorological station, either on ground or satellite data, or even you can do forecasting by connecting with the local cloud cover imagery. So in this case, you can get or you can estimate, or I can say it, okay, it's estimation or prediction, but at the end it will be accurate, like 95 to 98, let's say, percent accuracy, from my opinion. And in this case, you can estimate the predicted solar generation from the rooftop or from the PV system in general. In this case, you can find out, or you can compare the predicted value to the actual value at the site without going to the site. So with the smart monitoring, and thanks for the Wi-Fi and let's say the internet connection now, it's very easy to do that. So you can find out the exact, or the percentage, or the accuracy, or the difference between the actual and the predicted value. In this case, you can find if it's within the range, or underperforming, in the best case, overperforming, let's say. So you can optimize the performance of the project by getting, for example, an early warnings for any failure at the inverter level, string level, and what, as Omar said, now we can do it with optimizers at the module levels. This will enhance the O&M. By the way, this will decrease, of course, the cost of OPEX, of the operation, and you don't need to go and to find out the data, and to go and let's say start doing your exercise of comparing the data, calculating the data. It will be directly given by the system. So this is from the, let's say, for the inverter, or for the distribution, or the project side. And the most important thing that I want to here rise, that once we have this forecasting issues, once we have smart grid, and with the addition of AI and machine learning algorithm, the distribution companies can connect directly with the rooftop systems, what we call it distribution generation, and or decentralized generation. And in this case, they can even enhance the grid by contacting and dispatching the signal directly, even for 5 kilos, 10 kilos. Because if we have 5 kilos, 10 kilos in a certain area, we can collect around, for example, 0.5 to 1 mega. And this capacity can even provide enhancement to the grid by adding reactive power when they need, by stabilizing the voltage, the frequency. I'm talking about the small level of the distribution grid. So with this case, I prefer, and as we talked before, Samer, in many webinars, distribution generation is a very good solution, as a perfect solution to solve the grid issues. Of course, with the enhancement, and include the AI algorithm, the AI and machine learning in the setup. This is from my opinion, and whatever you have any question, I'm here, so I can answer any question regarding the inverter selection, even monitoring system, and how we can do testing and O&M for the projects. Yeah.
Thank you very much, Laith, but I just want to have a clarification what you said about monitoring the smalls, rooftop 4 and 5 kilos. And so what you're saying is that in the future we should expect the distribution companies to have a control station, monitoring center for the small scale PV. Is this feasible?
Yeah. Okay, I'm talking about the node level. As you know, the distribution has many nodes in many places. When you have AI, when you have direct or smart monitoring, it can easily connect it with the distribution. So the distribution grid will not do anything. Just they can let's say see the signal, the generation. With the forecasting, you can when you have any cutoff in a certain or not cutoff, a heavy load in a certain node. So you can even find out a solution, a quick solution using those distribution generation at a zone or a node of the connection with the grid, with the distribution grid.
Interesting, interesting. Okay,
Yeah.
thank you very much, Laith. I'm sure that we will have more questions later on in the Q&A session. Our next speaker is Mr. Ahmed. Mr. Ahmed, are you with us?
Yes,
Ahmed
Mr. Samer.
Monaji. تمام. Mr. Ahmed has 10 years experience in as an engineer. He's working for Danaway Energy based in Dubai. And he has total 7 years experience in the solar, completing over 100 megawatts, rooftops and utility scale projects. Yeah, and he has a master's degree from Harriet University. Mr. Ahmed, can you talk about the parameters that are needed to consider while selecting the right inverter? And you have 10 minutes. Thank you.
Definitely. Thank you, Mr. Samer, for your introduction. It was a pleasure to be here with you guys. Honestly, it's a lot of parameters that you have to consider to choose the right inverter. But from my point of view and for your time, I get it to only three questions or four questions that we have to ask ourselves each time that we are going to design our solar plant. First one is, how much size do I need? Okay, this plant is, if we are here talking about the utility scale or residential or commercial or industrial. What's the scale? What is our size that we are targeting? So if it's we talk about here, if it's residential, commercial, industrial, we are talking here about string inverters. If you go for utility scale, it's become central inverters. But nowadays, the guys are they say that okay, it's not only central inverters for central inverters for utility scale. Now we are also adding string inverters, and I will clarify why in mega projects. Like I did a project 50 megawatt in Uganda, in Togo. We used string inverters. We have another 70 megawatt. Also, we are going also to use the string inverters, and I will clarify why the reason of this one. So first thing, that what is the size that you are planning to use? Okay, then we go for what are applications, what is the application that you are going to use for this one. So if we are going for residential, industrial or commercial sectors, definitely you go for string inverters. Why? Because it's lightweight, and lightweight means easy for installation and less of disturbance. Of course, also we have this kind of safety for string inverters. If we are going to use the small inverters, we cannot go for um, big kilowatt inverters that can consume more time and more power from our system. This is the main thing. Again, for the central inverters, the main reason that we need to avoid it, because of if there is anything happen to the site and I have to switch off the inverter, that means I lost full 100% or 50% at least of my solar plant. But if I distribute this 100% to 10 string inverters, that means if I have a problem in one inverter, I have at least 90% of my plant will still produce power. One of the major things that also come to the parameters of choosing the inverters is the cost of the inverter. And I'm here not talking only about the capex cost, the initial cost. I'm talking about the operation and services and maintenance cost, replacement cost, because this is the major cost of the inverter. It's not coming in the cost of in initial cost. Omar here, he knows exactly initial cost of inverter. We talk about 2 cents up to 4 cents per watt peak, something like that. But if we go for operation and maintenance, solar modules doesn't cost a lot, but inverters are the major cost. We find fire happen at inverter side, not at solar module side. We find problems happen and this one, and the problem that it's not affecting only on the inverter, it's coming to the whole city, the whole connections, cables from inverter to the solar modules and cable from inverter to MV stations. So this kind of cost has to be considered as a major parameter, and I noticed that most of contractors neglect this effect on in their calculations. Also, one of the main thing that has to be considered is in calculations itself, power factor. And this power factor, most people neglect it because it's at sometimes they said, okay, it will be one, but actually during our works you have to make sure that you have your safe decision. Of course it affect on cost again of initial cost, but on long term this one will protect your plant and make sure that you will have stability in the grid, as as engineer Lubna clarified now. Because at the end of the day, inverters are the we can say that this is the mind of the plant. Without proper designing and taking care of all parameters of designing, and make sure that you are choosing not the best, because there is no best inverter in the whole world. Of course Omar will will not like my talk, because he said he thought that they are the best. Of course they are one of the best, but if you go to choose an inverter and say this inverter is the best inverter ever to use it for every application, this is no one accept this one. It's depend on what application you are going to use, depend on the what temperature you are going to use, because temperature has a major effect on solar modules, and a lot of people neglect this effect. you know it depend on the works regarding around the inverter installation. Okay, because the inverter itself and the inverter cost itself not that much high as we explained, but the BOS around it, this is what make it high. I hope I replied these three questions. Just every time you are designing a solar module, you have to think, okay, what is the size, what is the application, and what is the cost, and what is the total cost of installation, cost of the inverter, and cost of operation and maintenance for this inverter. Yeah, that's it. Thank you.
Thank you very much, Ahmed. Actually, very insightful, very deep thoughts coming from experience. I like to ask the attendees to write your questions to our speakers in the comments in the chat box, and we will read them out and direct them um, to the specific speaker. Um, Ahmed, I would like to ask you a question about your
Yes.
experience in the warranties,
Uh-huh.
inverter warranty,
Mhm.
because no one talked about the warranties. Uh, do you have any specific recommendations? And the second question is, how about spare parts? For how many spare inverters do
Mhm.
you need for example, let's say a 1 megawatt?
Okay, fine.
Thank you very much.
Yeah, most of it. Okay, so let's speak about warranties. Warranties
Yes.
for me, we talk about for me, for all my projects, minimum is 15 years. And don't go below than this one, because at 15 years you are sure as a company that you gain your money back. you know because yes, during our calculations nowadays we say that payback period will be 4.3 years, 4.2, 3.5, 3.7 years, but actually it's take more than that, because of a lot of factors that happens during installation, during the first year, and all this kind of all this time. So to make sure that as a company, and here I'm talking as a PPA and PPA agreements, and I'm talking here about not ABC that he's installed and leave it. No, I'm talking about the owner of the company itself, the one who is the developer of the solar project. He must take about 15 years minimum. This is my opinion. Second thing, we talk about the spare parts for inverters. This one depends on what size of string that you are using. So if you are using a string inverter of 100 kilowatt, so that means I'm using 10 inverters. Okay, so at this time I keep one in my site as a spare, but make sure that my developer, my supplier has in-house technical support in the same country. I was speaking with Omar about this one and Faris, of course, his colleague in Huawei, about the main thing that we consider in our choosing the supplier for us. If I have a problem inside, do you have the team who can support me in time? If he doesn't have, I have to keep more than one, because it take more time for me to replace, and time is money for me. So if I'm talking about 100 kilowatt inverter, so that means I lose every hour 100 kilowatt of my system. That comes to my bill at the end of the month. So if I have PPA agreement with the client, with performance ratio, with yield energy generation, so I have to achieve all this generation all the time. So it depends on the site, it depends on the supplier, it depends on location of your project, but minimum you have to keep at least one unit, but not more than three, to make cost effective calculations.
Thank you very much, Ahmed. Very good answer. Yes.
Mr. Samer, I'm having a small question if I can jump in now.
Yes, please.
Yes, okay. If you talked, if we're talking about the warranty things, which is like here, it comes to the statement for many. It comes to your mind many statements. If the suppliers commit to you as an officially that the inverter replacement, like for example, if we're talking about 1 megawatt, and Mr. Samer, the industrial is going very fast and it's developed very quickly now, especially manufacturing the internal components of any inverters. Like I'm talking about Huawei, like you can see the next technology of using more silicon components inside the inverter instead of using the old copper. That's why we're seeing the inverter is becoming less in weight. And the new technology of using like the new chipsets, or the silicon chipsets, or the silicon electrical component, it reached to a point that the inverter will be less and fail. Okay. Nowadays, for some projects for us, for example, for the residential, let's say up to 20 kilowatt, as we're talking between residential and small commercial, we are giving as a standard as a 10 years warranty. And was improvement into the global shipment, that the product will not be fail within this time, within this 10 years warranty. And adding another point, which is, if we're talking about availability of the project, when you're choosing your supplier, you should be having sufficient knowledge about the availability of the product. And this is something like we have to be always educating the end users and customers and EPCs about the facilities that we are providing. We are providing not just an inverter, but as well as a service. So it should be, this kinds of service should be available within the country itself, not to ship it back or not to get more people from outside to inside just to fix it. Okay. And you have to rely on a company that has already branches globally, because as Mr. Ahmed said, for some projects that we don't need to lose generation, the project goes into the financial loss if we keep the inverter just turned off. If there is a company that can provide me with the spare inverter within 48 hours, I would be more confident to use these kinds of suppliers, so I can get replacement directly if there is something happened. And this is my point, just to make it clear.
Yes, thank you very much, Omar, for this clarification. But the presence of spare parts is very important, and
yes, of course,
the availability. There is no warranty or against availability. So if the supplier doesn't have the inverter you will lose money until you get one shipped to you over a week or two. So
Yes,
yes,
exactly.
yeah. So as an owner, let's say for rooftops, if we're talking about large scale rooftops, you do need to have more than one, at least two or three pieces as spare, if you have, and of course normalize the inverters as much as possible. We have a question. I will direct this question to Laith. Laith, from your experience, what are the standards required for O&M? Laith, are you with us?
Yeah, yeah. Hi, Samir. Yeah. Actually, I didn't have in mind now the IEC number, but there are many. Let's say there are O&M standard, which is I think IEC 62446-2,
Yeah.
which focus on the O&M procedure and how to do the O&M for the projects. Another thing, there are many institute and organization worldwide have the best, let's say, I can say on them is a kind of common and best practice more than to follow a standard, by the way. For example, IRENA or NREL, they have their own publishment of O&M best practice and what to do at the site, including the health and safety issues. And to be honest, most of those norms and the reports are based on let's say, the general remote monitoring. And I didn't know yet. I didn't find any establishment or any report talking about the O&M using smart monitoring and how to deal with the problem and how to get the preventive maintenance alarm and to go to the site directly and to have this issue. I believe that it's a practice and as it's an experience issue to go to have this O&M. Of course, to follow the IEC is like a general procedure, but it depends on the experience. No.
Thank you, Laith. Ahmed, do you have anything to add regarding the O&M standards?
From our side, as Mr. Laith explained now, there is a standards of O&M that we have to follow every time. That okay, you have this kind of preventive maintenance. How will be the procedures of preventive maintenance? You have to make sure that you follow it as per the manufacturer standards to make sure that it will not come and conflict with his warranty procedures. You know, so for example, for our projects in utility scale, we make sure that okay, before we hand over to the client, we take all the procedures from manufacturers. This is how it will be. This is the brush type that we have to clean with. This is the if you go for wet cleaning, how many times? What will be the TDS amount in water to clean it up? What chemicals that can are used? But of course, we avoid all chemicals during our cleaning. This is the cleaning side. No, we go also for sorry, checking the systems, checking the inverters, checking the cables, every single item that we are doing. We 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 have to follow manufacturer procedures to make sure that it will not affect in your warranty. I don't want Amr to come to me and tell me, Ahmed, you didn't follow my procedures, so you are out of warranty. This kind of things is not mustn't happen. So most of time, make sure that whatever manufacturers say to you, you follow it. And of course, you have to consider your cleaning system will be perfect, because a lot of people neglect this point. They just clean it like okay, wet or dry cleaning, just remove dust. It's not only about this one. It's about how clean you are affecting to your solar modules layers, and how do you affect to the your cables connections, all these items. So yes, there is standards, and but the best standards with full respect to all people, is manufacturer standard to come not conflict with you.
Thank you very much, Ahmed. I have a question for Omar. Omar, are you with us?
Yes, I'm here.
Omar, at the beginning of your presentation, you talked about dongle,
Yes,
4G dongle or 5G.
yes. It's a 4G dongle actually.
It's a what?
4G dongle.
Yeah, this is the question: is why do we need to have a dongle and connect and buy a separate phone line if you have a local internet and you can connect to your local internet like any other device?
100%. هلا Mr. Samer, if we're talking about Jordan, like for example, let's say take Jordan as the market that we are speaking about.
Yeah,
Okay. Sometimes we're seeing some tenders that is going for supporting some residential or poor areas in Jordan to build a solar system, which is it's 2 kilowatt or 3 kilowatt system just to fulfill their needs of electricity. Okay. And sometimes when you're talking about level of people, okay, that the organization or the tendering system, some mosques in Jordan as well, they are built in really far and rare areas. And sometimes you can't find a local Wi-Fi dongle or Wi-Fi signal there. Okay, it's better as well for the developer of these projects to be having a full monitoring, just instead of sometimes waiting for the client just to call the EPC, just come and fix your system because it's not producing. The developer of the project, he should be having a full control on what's going on in his project, and he should be knowing remotely that this system it has a failure. That's why, like, one of the options that we are giving as well for the residential, and just to make it clear, for the Wi-Fi dongle or Wi-Fi signal or Wi-Fi compatibility with the inverter, it comes up to the 10 kilowatt. Okay, just talking about the 4G, as I said, the developer of the project, he should be having this access. Like if you're talking about IV curve or string level monitoring, all of these signals or just results that can help the developer how when I need the O&M. I don't need to send my guys every month once to a site. If there is something happened, I will be sending my guys there or my technician to the site. But if there is nothing happen, I will be keep following on my system. That's why we give two options about 4G and Wi-Fi compatibility.
so you have Wi-Fi compatible?
Yes, the Wi-Fi is available up to all inverters, like even the 36, 40, 50, 50 kilowatt inverters. Okay, in this case, yes, we're having Wi-Fi, and it's already coming built in within the inverters up to 10 kilowatt. Like it comes built in within the system. Even for the single phase, it's come as well built in.
Yeah, but Omar, because I had an issue with the client and we needed to buy a dongle. The dongle, as you know, you need a separate line, and that will cost 200 JD minimum per year. So that's a lot of money compared to the cost of the inverter. So
Okay,
over the lifetime of the inverter. So this is if you have a Wi-Fi, a local
yes,
area network should connect to it. And I was very surprised that the inverters did not have this Wi-Fi.
no, it has a Wi-Fi. It depends on the project size. Actually, it depends on the inverter that you are using.
Okay. Maybe,
Sometimes when
yeah,
we're going towards 60 kilowatt inverter or 50 kilowatt inverter, the minimum of these project sizes should be 1 mega or 1 point. يعني it should be around the mega scale projects. When you towards the 60 or the 50 KTL inverters. So in this case, we believe that the project size will be you should be using a smart logger. Smart logger because you need the full control for all inverters. Even the dongles, the Wi-Fi dongles can support up to 10 inverters. But when the project's going into mega scale, okay, I need a smart logger. You need a logger to logger your data in. Instead, as well, for the logger as a second option, we are providing a 4G dongle.
thank you very much, Omar. Thank you. We have a question about the losses in inverter and the heat impact.
Yes.
So, Omar, you want to talk about this as well?
Yes, talking about the heat technology or heat systems, like our patents that Huawei took for the cooling methods that are already taken from our carrier business, because Huawei the biggest line they're having is the networking and communication systems. When we're talking about far areas or rare areas, okay, we should be having these equipments within the standards of heating. We took the technology from our carrier business and implemented in our solar inverters. That's why you're seeing the forced, or we call it smart air cooling system, when you are towards 100 kilowatt. When we know that there is a sufficient number of DC that are coming into the inverter, and the equipment needs to be cooled. We developed something called smart cooling system or intelligent cooling system regarding the fans. Okay, but when we're talking about smaller inverters, our technology of the heat sinks, it can support the inverter up to 50 and 60 degrees. Like Ahmed is very familiar with these kinds of environment, especially in the Gulf region. When we're talking about the sites that reach 50 and 55 degree under the sun, so the inverter cooling system should be sufficient to do this.
Yeah, no, we are well aware of that. The question was about the impact or the effect, the impact. So there should be a graph of loss of efficiency with time, with temperature. So
Yes.
the higher the temperature, you will lose efficiency. But
General.
usually, the suppliers don't publish that. Ayman Al Jamili asked this question, but I'm not sure if Omar, you are publishing that.
Actually, yes, the PQ curve, actually what we call it PQ curve, that shows the inverter degradation over the temperature. Okay, this is available, like we can share it, and the design team should be aware about the environment that I'm installing the inverter is. But yes, the PQ curve, we can share it for any inverter you requested.
تمام. So Mr. Ayman and Mr. Tamim, yes, there is an impact for the temperature, and this is usually this curve you can get it upon request from the inverter manufacturer. So you have to, let's say, it's not published, but you have to ask for it. We have a question about AI. So Laith, are you with us? Laith?
Yes, I'm here.
So Tamim is asking what are the application, or what is the application of AI for solar power systems. So maybe you can elaborate some more about AI and solar PV, so the audience and the attendees can understand more about this application.
Okay. So, following the technology now, what I'm saying nowadays, the AI, or everybody talk about AI. AI is a tool, let's say, is an interactive tool and algorithm that compare or that predict, let's say, the energy yield, or what should be generated from the PV system, as I said before, compared to the expected generation based on the weather condition. So, and let me explain a bit technically. If you have a PV system, sorry, hello.
Yes, go ahead.
Okay. If you have a PV system, you have like X amount of generation on daily basis or on hourly basis. But if you have a device that even collect or record the radiation, record the temperature, record even the surface cell temperature, as we call it, the meteorological data, you can even expect and calculate the expected generation. If you have an accurate data, the model will be, of course, accurate and close to the actual value. Sorry, not to the actual value, but close to or with a minimal uncertainty. So once you have the actual energy and you have the generate or the expected energy, you can find the deviation from the actual to the predicted, let's say it like that, and then you can find if there is any problem or no. So this can be either on monthly basis, on yearly basis, even on 5-minute basis. It depends on the let's say solution. On the other way, once you have a smart grid, as your question also you mentioned a bidirectional flow, when you have a bidirectional flow between the PV system and the grid itself, a kind of two-way electricity information, let's say, between the distributor and or the provider and your system, it can be even controlled by the operator. I'm not saying about control like on or off. Of course, he can turn it on or off. But what I mean by that, he can help his grid from your system by introducing reactive power when needed. As most of the inverters now, especially the commercial one, it can provide Q at night, reactive power at night, and the utility grid can produce from your inverter the reactive power, or it can be even within the day, produce reactive power when needed to stabilize the grid voltage, for example. So what I can say, the AI will be in the future the brain of the smart grid. We hope that we will have a smart grid in Jordan. So everything will be collected at one node, and everything can talk together and between the distributor and the system. So with this solution, this concept, I think it's used worldwide in let's say in the countries like Germany, like US, and we hope that we can have it here. And with this solution, as I said before, decentralized generation will be the solution for the grid in order to enhance it whenever by the distributor.
Thank you very much, Life. I have another question for Omar, and then maybe later on, Life can support Omar. Omar, are you with us?
Yes, I'm here.
Omar, can you just brief us about the available self-testing, self-diagnostic for the inverters that you have?
But I didn't get your question.
The question is about the self-testing that the inverter can do.
Self-testing, like
Yeah.
you mean regarding to detect any failure in the inverter?
Exactly. Yes.
Yes, so to detect any failure, this is an algorithm, I think, within within the sorry, but it should be within the inverter itself. As long as the inverter detect any failure, okay, let's say major failures that needs an alarm, the inverter will be giving directly an alarm to the end user or to the developer, someone who's connecting with this inverter. That's why the monitoring is really important. Okay, that there is an alarm for something, that there is something happened to the inverter. Okay, for minor issues, let's say, and supporting Mr. Laith as well for his idea about the testing and IV curve testing, and these all tests can help as well the people who's working for the consultant to detect any failure that happens to their project. Like if I'm doing an IV curve, I can scan all of the strings and how it's performed according to the standards. This is covering the major and minor failures, let's say.
Yeah, because maybe this is one of the unique things that Huawei inverters has.
Yes.
The
IV curve.
testing. Yes.
The IV curve, yes, the IV curve is, it helps as well the consultant when we're doing. Of course, there is a need of some companies to be consulting and doing an IV curve like in the normal way, let's say it, okay. But for a big plans, when the project's going into utility for big projects, let's say 50 megawatt or above, okay, we should be having a smart way of doing these IV curve. So we can have a full report, and this report should be certified by someone. Okay, like I can just, a supplier comes to the end user and say, okay, I can generate for you a report for the IV curve parameters. No, who tested these reports? Who tested the accuracy of the sensor that it has? Then it becomes to a third-party certified system. That's why our IV curve is certified, for example, by TUV. Okay. then the consultant, the local consultant in the country, he should be giving his inputs as well for this plan. Like, of course, Mr. Laith, he's doing this, like comparing the results between the normal or the standard results and within the results, that the numbers that he has it from the site. That's why he will definitely know how health is the power plant is.
Okay. Thank you very much, Omar. We have a question.
I have a question, Engineer Samer.
Lubna, yes.
Yes, I have a question about how to choose between string and central inverters in utility scale installation, especially that we know that a string inverter come with benefits about energy optimization, that's essentially balancing of volts and ampere in power conversion. But we know that a central inverter is cheaper than a string inverter. How I can choose in large scale project like 100 mega as example? This is a question for Omar.
Question for Omar. Okay, Omar.
هلا actually لبنى يعني طلع look هلا if you're talking it in general يعني for me as a personal I will be promoting the idea of using string inverters as long as I'm coming from background of using string inverters, but the developers or EPCs like they can answer this question. Actually, when you're using central inverter, you will be having a major not say problem but limitation in the availability. Like when something happened to the inverter, when you're switching an inverter with a central type of 2 or 3 megawatt, then when the project goes to 100 mega scale, okay, we see that there is an issue in availability. As well as for, don't look at it as just an capex system, but just an opex. Like we're seeing the industrial is moving very fast, and just relying on the technologies that it was available on the central inverter, okay, and the limitation that it has, it either from the grid, from the cables, from the design, from the heat, from everything. We have to take it in consideration. This is the main benefit of using string compared to central. That's why we see also the utility and big projects, when you're coming to giga scale, they are going with the string inverters because they know how the opex will be performed. I hope that I answered your question.
Yes, thank you, Omar.
It's a big question, and Lubna has to do a lot of research. I'm sure you can talk about it more later on by special chat. We have a final question. It goes to Lubna. It's about harmonics, the power quality and harmonics distortion. What causes them and what effects it has on the project? Lubna?
Yes, Engineer Samer. The harmonic distortion affects the on the wave, on the electricity wave. So this make a very big problem for electronic devices or any load connected with the plant and affect the transformer in power losses or a heat or any other problems comes from harmonic distortion.
Okay, Lubna. Now we have. I want to ask Farah final question. Farah, are you with us? Farah is not with us.
No. Yes, I'm here. Yes.
Okay.
It took me a while to initiate.
No problem. Farah, I just want to ask you from your experience during the past 10 years in the inverter rooftop industry. The technology has evolved, and the customers with inverters, what kind of problems they are facing, and what is your recommendation for future customers?
Okay. Actually, because we were using one source of reliable inverters since day one, since 10 years ago, we didn't really face any problems. I remember one time our company or the manufacturer that we buy inverters from them were manufacturing or were testing some new type of inverters. It had some technical problems, but it was solved later on. However, I heard about a lot of problems in the generation of the some of the not so popular types of inverters, because at a certain time in Jordan, it was allowed that any type of inverter to be installed, and after that there was some restrictions for the specifications. The issue that some of the inverters that are not really popular were not having a service center for the they were not having a service center for the company, either the EPC or the manufacturer in the region, and in Jordan in specific. So the owner was stuck in between. He cannot benefit from the production of the system, and at the same time he cannot do anything to fix his inverter. So there was so many replacements of the not so popular inverters. That's why we always convince or try to tell the project owners to only use the best of the inverters that are available in the market.
Thank you very much. Now I would like to ask the speakers for one last recommendation to the attendees, and I will go backwards. So, Ahmed, are you with us?
Yes, Mr. Samer, yes.
Yeah, in one sentence, what is your recommendation for the attendees?
Okay, one sentence. Go for solar, go for trusted manufacturers, and go for trusted ABCs. Don't go for lowest prices.
Thank you very much. Very good advice. Laith, are you with us?
Yes, yes.
Yes.
I,
Your
I can say everybody, yeah, everybody should cope with the technology and follow the new technology, of course, to focus on the after sales support.
Thank you very much, Laith. Lubna, do you have any recommendation?
Yes, of
One
course.
line. Yes.
Just learn more about renewable energy. We need a lot of researchers nowadays.
Very well. Thank you very much.
Welcome.
Farah?
Yes, my advice actually will be to the project owners. The energy yield is what the most important thing that it matters, because you are installing a PV system or any type of renewable energy system in order to gain electricity. So pay the most attention to the energy yield, and of course this will come by using very trusted components for the PV system, and take good care of the operation and maintenance for your systems.
Excellent, Farah. Thank you very much. And last but not least, our dear Mr. Omar.
Habibi, and I would say educational is the most important thing. Like we have to keep following the latest technology, latest things that it's giving by the manufacturing, what support we can give as well. We have to keep learning about this industry. Like it's like the any technology provider, we have to keep following on these technologies, like the mobile phone.
Perfect. Thank you very much,
Thank
Mr.
you.
Anand. Do you have any last final words?
Yes, sir. So maybe you can also give your summary, sir, of this discussion.
My summary is this is was a very interesting discussion. All the speakers were highly competent and shared their experience honestly. Definitely, there is a lot of room for further discussions and more detailed topics. And I hope that the speakers had fun and we thank them very much, and we hope the attendees learned something new during the past 90 minutes. And of course, final thanks to the organizers, Solar Quarter and Anand in specific.
Thank you. Thank you very much to all our esteemed panel for a wonderful discussion, and a very special thanks to Samir sir for superbly managing the session. Thank you everyone for extending your time and support for the event. We promise you to come back with more exciting topics very soon. The floor is now
Thank
open
you.
for networking. Thank you so much.
Thank you,
Thank
Yeah.
Anand.
you.
Thank you.
Thank
Thank
you,
you
everyone.
very much.
Thank
Thank
you.
you all.
Thank you. Thank you,
Thank
everyone.
you all. Yeah. Bye
Thank
bye.
you.
Bye bye.